Number 66. Citric acid, which is C6H8O7, a component of jams, jellies, and fruity soft drinks, is prepared industrially via fermentation of sucrose by the mold Aspergillus niger. The equation representing this reaction is this. So we have sucrose, which is C12H22O11 plus water, H2O plus 3 O2s, which will produce 2 citric acids and 4 waters. What mass of citric acid is produced from exactly 1 metric ton, which is 1 times 10 to the 3 kilograms, of sucrose if the yield is 92.30%? Okie dokie. You guys know what I'm going to do, right? First thing I always do is I go for that balance equation. I'm just going to rewrite it, bigger just so that we can work with it better. So we have the sucrose, C12H22O11, plus water. Now, technically, you can simplify this because there's water on this side and water on this side, but, just not to mess up the oxygens or whatever, I'm just going to, write it as it is. 2 C6H8O7 plus 4 H2Os. Okay. Now, can I get lucky and maybe, bring this over and not mess up the problem? Ah, nice. Okay. So here we go. Always write down what you're given. They told us that we had exactly 1 metric ton of 1 times 10 to the 3rd kilograms of sucrose, and this is sucrose. So I have 1.000 times 10 to the 3rd kilograms of sucrose, so that's my starting material. And they're asking for what mass of citric acid. This is the citric acid. So I need to find out what the amount is this, right? Now, the first thing is when we're doing stoichiometry, I really don't like to use kilograms, especially when I remember my stoichiometry, flow diagram as grams to moles to moles to grams. So the first thing I'm going to do is I'm just going to convert this into grams, right? And we can always go from kilograms to grams by timesing by 1,000, right? So we already have a lot of kilograms here. We have 1 times 10 to the 3rd. So we basically have 1,000 kilograms. And I'm going to times that again by 1,000. So now I have 1.00 times 10 to the 6th grams. Even though it's a big number, I just like to use grams. 1, 2, 3, 4, 5, 6. Okay, perfect. Okay, now I'm going to use my stoichiometry here because I know what I'm starting with and I know what I'm ending with. We've done tons of problems like this. So this is going to kind of be like the quick version here. So I can get the grams of the sucrose, where I'm starting with that, right? C12H22O11, and I'm starting with 1.000 times 10 to the 6th grams of that. I can find out what the moles of that is. Whoop. Get rid of that. And I can go to moles of C12H22O11. Then I can go to sucrose. So let me just make a little bit more of room for myself. So that's C6H8O7. And then from there, I could find out the grams of the sucrose, C6H8O7. Now, why are we doing that, right? They want us to know what the mass of the citric acid is. So I need to know this. And we're just going to add something new here. This amount that you're finding of your product is called the theoretical yield. This is the amount of product that you can make if no mistakes happen, if there is no error. If there was an ideal, perfect world, this is the amount of grams we would make at its max. So let's just figure it out. 1.000 times 10 to the 6th, and then we have grams of the sucrose, 11, times, maybe I'll do it in black like I usually do, times it by a ratio. We're going to put the grams of the C12H22O11 on the bottom. And then we're going to put the moles of the C12H22 on the top, right, O11. And remember, this is the periodic table, right? A gram to mole reaction or ratio is just a periodic table. And remember, it's always 1 mole, right? The number that you find on the periodic table goes with the grams. So I got 12 carbons, so 12 times 12.01, plus 22 hydrogens, so 22 times basically 1, and then 11 oxygens, so 11 times 16. So I get roughly a big number, 342.296. Okay, cancel those out. Let's move on to the next one. Mole of sucrose goes on the bottom. And now we're going to move over to the citric acid. So that's moles, because that's what's coming up next. C6H8O7. What numbers go in here? This is your balanced equation. So that's why it's super important to know your coefficients. In here, since they gave us coefficients already, I'm going to assume that this is already balanced. So for the sucrose, there was no number here, right? So that means that there was just 1. So there was just 1 of these. So that's why there's a 1 here. And then for the citric acid, there was a 2 here. So I'm going to put a 2. And then finally, let's just get those in grams. So mole of C6H8O7 on the bottom, and grams of C6H8O7 go on the top. This is also the periodic table. So 1 mole, because when you use the periodic table, it's always 1 mole. Then get the mass that goes with the grams. So 6 times 12.01 for carbon, 8 plus the 1 for the hydrogen, and then 7 times 16. I get basically 193.068. And then let me just maybe, okay, then it's 6.8. Okay, so cross this off. We're now going to find the theoretical yield of this, the citric acid. So let's see, 1 times 10 to the 6th divided by 342.296 times 2 times 193.068. I got a big number. So we could cut it off after a couple of places. So I'll say 1, actually, I guess I will put this in, we'll put it in grams and then we can put it back into kilograms. It doesn't really matter. 1.128 times 10 to the 6. And that's grams of the C6H8O7, so the sucrose. And that is your theoretical yield. But they wanted to know what was the mass of the citric acid if we had a percent yield of 92%. So basically, if the theoretical yield is 100%, it's the max amount that we can produce with no error, what would I be able to produce when I only produce 92% of this? So we can, just basically do a percent formula, but if you want to know what the specific percent yield formula is, it's this guy. So I'll maybe put it a little bit smaller. Now, the actual yield is what you actually produce, and the theoretical yield is always the one that we produce with stoichiometry. So this is 1.128 times 10 to the 6th grams. They told us the percent yield was 92.30%. So basically they're just asking what x is. So 92.30 equals x over 1.128 times 10 to the 6th and then times 100. Okay, cool. So just divide by 100. You're basically solving for x. So if I just get rid of this just for space, this would cancel out, right, guys? And then we're left with 0.9230. 0.9230, cross multiply, and we get our amount. So we'll get x equals 0.9230 times 1.128 times 10 to the 6th. So basically 1.04 and 3 sig figs. 4 sig figs actually here. So 1.041 times 10 to the 1, 2, 3, 4, 5, 6. And that's grams of the citric acid. So if you need it in kilograms, this would basically be 1.041 times 10 to the 3rd kilograms, because you're dividing by 1,000. And that's it, guys. What do you think? Hopefully this helped. A lot of math, but we got it. All right? Step by step, okay? I believe in you guys, and good luck on your future tests and quizzes. Let's keep studying hard, and I'll see you in future lessons. Okay? Bye-bye.